Music and uses of sound. Now, we've been talking about going to concerts and orchestras and pep rallies, and many times at these functions we have music, of course. But what is music? Well, we know that music and noise are caused by vibrations, but noise has random patterns and pitches, where music is made of sounds that are deliberately used in regular pattern. Any object that vibrates has a particular set of frequency at which it vibrates. These are an object's natural frequencies. When you pluck a guitar string, the pitch you hear depends on that string's natural frequency. There are different strings on a guitar, and each one has its own set of natural frequencies. The natural frequency of the guitar string depends on the string's thickness, its length, the material it's made from, and how tightly it's stretched. Musical instruments range with so many different strings, membranes, or even columns of air that vibrate at their natural frequencies to produce notes with different pitches. Going back to the guitar string example, the natural frequency is produced by the entire string vibrating back and forth. But in addition to this vibration, the string also vibrates to produce overtones. An overtone is a vibration whose frequency is a multiple of that natural frequency. So when you play the first two guitar strings, these overtones create the rich sounds of a guitar. The number and intensity of overtones vary with each instrument, and these are what is used to produce each instrument's distinct sound quality. Now, a musical instrument is any device used to produce a musical sound. Cellos, horns, drums, and violins are all musical instruments that you might have seen or heard. Now, all these instruments and many more use resonators, or hollow chambers that help amplify the sound when the air inside vibrates. String instruments have sound produced by plucking or striking or drawing a bow across tightly stretched strings. Because the sound of a vibrating string is soft, a string instrument has a resonator to amplify it. If you pluck a guitar string that is stretched tightly between two nails on a board, the sound is very quiet. But when the string is attached to the guitar and the guitar frame, and the air inside the instrument begins to vibrate as they absorb the energy from the vibrating string, the vibration of the guitar body and the air inside the resonator makes the sound of the string louder and also affects the quality of the sound. Brass and woodwind instruments also have resonators. Brass instruments have cone-shaped mouthpieces, and this mouthpiece is inserted into metal tubing, which is the resonator in the brass instruments. Now, as the player blows into the instrument, his or her lips vibrate against the mouthpiece, and the air in the resonator starts to vibrate, producing a pitch. In some instruments, the musician can change the length of the resonator by opening and closing finger holes or valves. In a trombone, even the tubing slides in and out to become shorter or longer. Percussion instruments are struck, or you can shake them, or you can rub them or brush them to produce sounds. Drums have a membrane that is kind of stretched over a resonator, and when the drummer strikes the membrane with sticks or a hand, that membrane vibrates and causes the air inside the resonator to vibrate. Now, if you've ever sat in a band room or been around a lot of people playing different instruments, you'll notice that the sounds and their reflections reach your ears at different times, and you might start hearing echoes too. These echoes are produced by reflections of sound called reverberations. If you are at a concert and all these reverberations were occurring, it would ruin the sound of the music. So to prevent this problem, engineers who design concert halls or anywhere where music is played needs to understand how a room affects the reflection of sound waves. This understanding is what is called acoustics, or the study of sound. Now, another use of sound is sonar. A sonar is a system that uses the reflection of underwater sound waves to detect objects. First, a sound pulse is emitted toward the bottom of the ocean, and then the sound travels through the water and is reflected when it hits something solid. A sensitive underwater microphone called a hydrophone picks up the reflected signal, and because the speed of the sound in water is known, the distance to the object can be calculated by measuring how much time passes between emitting the sound pulse and receiving the reflected signal. Now, sonar was first created to detect underwater objects such as icebergs, but now it's used on Navy ships to locate and identify submarines. Fishing crews can use sonar to find schools of fish, and scientists are now using sonar to map the ocean floor. Bats and dolphins use sound to locate objects in a process called echolocation. This is a process of locating objects by emitting sounds and interpreting the sound waves that are reflected back. Bats emit an ultrasonic or a very high frequency sound. The sound waves are going to bounce off the objects and then locate the prey by using the returning echoes. By emitting a continuous stream of ultrasonic cries, the bat can hone in on its prey and capture it for a meal. Instead of the high frequency cries, dolphins use a continuous clicking sound when they hunt and use echolocation. High-frequency sound waves are used in more than just echolocation and sonar. One of the most important uses of ultrasonic waves is in medicine. Using special instruments, medical professionals can send ultrasonic waves into a specific part of the patient's body, and those reflected ultrasonic waves are used to detect and monitor conditions such as pregnancy, heart disease, and even cancer. All right, let's take a break, and it's time to show what you know.